It's going. Oh,
Purple.
Mr. Nadolny told me this one time that you can like milk. No, a whale. You can milk a whale.
Whales don't have udders.
Yeah, but getting the whale to stand
But they're
still,
mammals.
Getting the whale to stand still is going to be the toughest part of that, you know.
You knock it out.
Or holding your breath that far in the water. So, example 61.3. Bring that bunny trail back.
Do you want
Okay.
me to read it for you?
No, I got it. 61.3. Virginia and Campbell, okay, had 100 kilograms of a 20% glycol solution. Then they need to, they've got a 40% solution that they're going to add to get a solution that's 35. And, okay, as usual, these problems, you always start with the volume. How much plus how much equals how much. Actually, sometimes it's a minus, usually it's plus. Let's make sure that it's plus here. They have 100 kilograms of 20% glycol, and they're going to add some to get a different concentration. So they are starting with 100 kilograms, and they're going to add, what should we call it?
50.
Not glycol.
Well, yeah, we don't know how much.
WM.
No, SS.
WM.
Susan Straw.
I don't like using S's.
WM.
What?
WM.
WM?
That's
What
like
is-
a
Whale milk.
What?
Whale milk.
Wow.
Whale.
Whale milk. Oh dear. I don't think there's any glycol in whale milk, but sure, why
You
not?
can add some.
And so we were given the starting amount, and when we're given the starting amount, just you can make a mental note of this or write it on your formula sheet. When we are given the starting amount, you're going to end up with the dye equation. Were you here for the dye equation, Shannon?
Yes.
Okay. So 100 plus WM equals 100 plus WM, and we'll put that in parentheses. Then we move on to our percent concentration equation, and this is talking about percent glycol. Glycol. And as usual, we're going to copy down our volume equation, leaving some space. Please put the scissors down. 100 plus Wn. Thank you. Oops. And so we need to put in the concentrations here. The 100 kilograms that we're starting with, what is the percent glycol of what we're starting with? Example 61.3.
Come on, Shannon.
That's right. This way. Okay, 20% glycol. And it says, it's asking how much of a 40% glycol to add. So that was 40. And they need to end with what concentration?
35.
35%.
35. So now we have an equation that only has the one unknown, which is WM, which is just ridiculous, but it doesn't really matter what the variable is, because when you solve for the variable, you're going to come up with a number, and you have to have the units anyway. And so that's how you finish that one off. Okay. Now, last example here.
Pink.
Pink. I don't have pink.
Orange. Orange.
Fine.
Too late anyway.
You guys are not. Okay.
I'm going to make some room here. So back to example 61.1. We have how much water must be evaporated from 100 gallons. The 100 gallons that's our volume. We always start with volume. Volume. Now the 100 gallons. Are we starting with that, or are we ending with that?
We're starting with 100 gallons.
Okay, so we're starting with 100 gallons.
With a 40% brine.
We're starting with 100 gallons. We leave the percentages until step 2, till the next one. That's one thing you can try to remember to help you get started correctly. Always start with the volume, and so when you're looking for your volume equation, ignore all of the numbers that have a percent with them.
So that we don't have an ending solution.
Okay, so we're starting with 100 gallons, and do we know how much we're ending with?
No.
No, we don't. It's going to be a dud type of equation. What are we doing?
Evaporation.
How much water must be evaporated from 100 gallons?
Minus.
We're going to be evaporating out something. We're actually going to end up with less than 100. And what I like to do anytime we're evaporating something is use an E. It doesn't matter what letter you use. And again, since we were given a starting volume, it's a duh equation. So 100 minus E equals 100 minus E. Duh. Okay. So, percent concentration. We copy down our volume equation, leaving space to put in the percentages. Now, what percentages are we going to put in? By the way, brine,
10% and 40%.
the word brine is a word for salt water. And so it's a mixture of water and salt. Water and salt, just so you know.
Just get more dehydrated, not unnatural.
So we're starting with 100 gallons of a 10% brine solution. So should I put 10 here?
Yes.
Right. Now, 10% brine solution means that this is salt. Brine is actually, well, yeah. Brine is salt.
I have a kid in my class named Brian.
Okay, so if we're talking about, that's nice. If we're talking about percent salt, the 100 gallons is 10% salt. What do we need to end up with?
Then 40%.
40%. 40% brine solution. Now, we are evaporating out water.
Yes.
How much salt is in water?
50%. Halvesies. Yeah.
Let me be a little more specific. How much salt is in pure water?
Nothing.
No.
No.
Pure
No
water.
percent.
0.
There is 0% salt in water.
Yeah.
What about
So
salt
we-
water?
So, so we're evaporating out water, we're not evaporating out salt water. We have salt water, we're getting rid of water. So we have 10% salt or the 100 gallons that is 10% salt. We are evaporating out a certain amount that has no salt in it. And we're left with this volume that is 40% salt.
Okay.
And notice what happens here, minus 0E, this term goes away and you don't have to worry about it. Now, just because the book did this, and just to make the point, you have to be consistent all the way across. If this is if this volume is 10% salt and this is 40% salt, whatever this volume is, you better have this percentage be the percent salt. We could do it as percent water. And then we'll end up with it. We'll end up with this. Our same volumes, right? If this 100 gallons, if 10% of it is salt, how much of it is water? 90.
Nice.
What we're ending with, if 40% is salt, how much of it is water? Of the water that we're evaporating, how much of it is water? All of it.
100.
So again, a reminder, when you have the duh equation, not always, but many times, your second term is often going to be 0 or 100.
This has been
So make sure you read the problem carefully. Have a schmathy day.
Meow, meow.